Hi, my name is Charles Woolridge. I'm an applications engineer with GoEngineer. Today's webinar is on using SOLIDWORKS, CAMWorks, Lathe. This is a getting started video. Let's go ahead and jump right into SOLIDWORKS. So here's the part. This is a lathe part that we'll be turning. I'm going to go through the steps that you'll need to do to process this part. So one of the first things you want to make sure that if you're using SOLIDWORKS 2018 that you have the CAMWorks module selected and you don't have CAMWorks 2018 selected. Let me show you how to select that. So what we'll want to do is come here to the options, select down, check our add-ins, and make sure that we have deselected the SOLIDWORKS CAM 2018 option here and here, and make sure we have CAMWorks and CAMWorks 2018 utilities both as the active add-ins. If you have it set up such that you have CAM active and not CAMWorks, you have to select the CAMWorks to be the active add-in, shut down SOLIDWORKS, and restart SOLIDWORKS, and then open your file, and you start processing your file. So again, I already have the SOLIDWORKS CAMWorks 2018 set up, so I'm going to my CAMWorks tab here, and then I'm going to go to my Define Machine here, and that will open a window for me to start processing. So we'll start from left to right. We'll start with our machine. We'll go down and select a turn single turret. Make sure we positively select that. We'll select a tool crib. Make sure we have tool crib 2, the rear. This is the tool crib I'm going to use. And these are the tools that we're using. Post processor. We're going to go down, and today we're going to use a Haas post processor. Right here, Haas ST20. Make sure I positively select that. You notice that when I select, it changes the active post processor. I'm going to go to my posting. I'm going to check to see what program number I'm going to be outputting to the program. Typically, you don't want to start at 1. Well, today we'll just start with 1001. And then we'll go to our chuck fixture, and we're not going to use a 4-inch chuck. Let's go ahead and use a 10-inch chuck. Let's go to Edit. Come over here, look to see what we have available. We do have a 10-inch 3-step chuck. If you didn't have one, you could set it up here very easily, selecting the OD, ID, and the thickness of the chuck, and then whether you want jaws in, jaws out, number of jaws, number of steps, and finally the jaw thickness, and you would save it. But since I already have it built out, we'll just go ahead and use it. We'll say OK. Set up a coordinate system. And we'll notice that the coordinate system is correct. We see the Z and the X is in the correct location. We'll say OK. And then come to our stock manager. And in stock manager, going top bottom, select the material that we'll be cutting. In this case, we'll be cutting 6061 T6. That's important because the machine will use the library and it'll use the material that you select here to actually set the feeds and speeds. And then the stock type, we have typically on a lathe using round bar. So you can use round bar stock. You can set it off from a revolve sketch, from a work in process file, WIP file, an STL file, or a part file. In this case, again, we're just going to use round bar stock. And then you'll see next bar stock parameters. We'll skip down to the next section, and we're going to actually create some offsets here. So I'm going to set a diameter offset of 100 thou. I'm going to set 100 thou from the face of the stock, and then I'm going to add 1.2 inches. So again, I just updated these parameters here, and I'm going to set that as my default. So next time if I get this part, I can just automatically set that stock. I'll say OK. Now go to Setup, Turn Setup, and again I'll see that the axes are correctly X and the Z. Say OK. So you'll see that the system does a lot of the heavy lifting here. Again, what I'm using is a straight standard out of the box setup to do this. This is the same system you would have if you just installed SOLIDWORks CAMWorks on your system. This is how your system would respond. So now we'll just go to extract our machinable features. This is what are we going to cut, and then you'll see the system here. We'll have the blue telling us that we have a face feature, OD feature, and a cutoff feature. And you'll notice on the screen it's highlighted in blue. When you see the blue line here, and as I move up, you see the OD, the blue line, and then the cutoff feature, again, the blue line. So we determined on what we want to cut. Now we got to decide how we're going to cut it. So we'll go to Generate Operation Plan. As you'll notice, as I select these items here, I did the Extract Machinable Features. They made the Generate Operation Plan button available. Once I select that button, the next button, Generate Toolpath, Simulate Toolpath, and so on and so forth. So let's go ahead and generate an operation plan. This is going to determine how we're going to cut it. So now we see we're going to do a face rough, a face finish, a turn rough, a turn finish, and then a cutoff. And again, also the tools and the turret locations is located here. So now you'll see that generate toolpath is available to us. So I'll generate toolpath, and then I can see all the different steps. And then I can simulate that. I've slowed it down here. You'll notice I could speed it all the way up, but I'm going to do it half speed. We'll see that it's showing the turn operation. And then we have a display option here. The green just means that it's to size. The blue means it's undercut. And this part is made right to size. The next step in this process is you would post-process this file. So now we're going to tell the system where do we want to save the output, and we'll select NC code as the output location. So now that we said where we want to save, we actually got to translate the CAD and have the CAM system output G code. So let's go ahead and do that. We have two options. We can do fast. You'll see it just processes it. Or we can say, let's see the code. And again, you see the code here. And then in our options, we want to make sure we open this in the G code editor. And you'll see the file opens up. And you'll see that I have a backplot window set up. Right now you'll see that I'm using a default post processor. So there's no support on it. And we go down, we see all the different G-code options. Now, this is an actual G-code simulator, so as it goes through, it's actually doing what the machine is being told from the CAM system. Okay, let me go back through this and let me explain some of the parts real quick. Again, you saw how fast it is to output code. Now, I say that it's really quick, but there is a learning process here. The code that you get is about 90 to 95% ready to go. What's important is that last 5 to 10%, which is your feeds and speeds, because this is going to be particular to your setup, your machine, your work holding, your tooling, and the material that you're using. So all those things are go into your feeds and speeds. But again, this is generally very good, but you want to check it again to make against your setup. So let me go ahead and close this file and restart it. I'm not going to save it. And let me just reopen that file. Okay, defining the machine. This is where we determine what machine we're going to be using. Again, turn signal, turn, single turret. We select, positively select that, so it pulls it over. And then we'll go to our tool crib. And again, these are the tools that come default. You can change tools based on your needs, but again, I'm just going with the defaults out of the box. Let's make this run. And we want to make sure we positively select that, make sure it's selected. Post processor, we're using the Haas SC20. Make sure we positively select it, because even though we selected in this part of the screen, we still need to select it here so that we change it in the active post processor. And then we go to posting and we change the program number to what we want. Let's just say 1002. And this is just the program number that's inside the G code, not the actual file name, which we set later. We'll set our chuck. We don't want to use a 4-inch, we want to use a 10-inch. And actually, let's go ahead and create an 8-inch two-step jaw. So we'll go here to 8-inch. We'll change the name from 8-inch 3-step to 8-inch 2-step here. I'll hit save. That's okay, I'm just going to overwrite the one that I have. And we'll change this from number jaws from 6 to here. Change it to 2 jaws. Excuse me, 3 jaws is what we want. And we'll change the number of steps to 2. Jaw thickness. And we will make these, keep them jaws out. Save again. And that's the jaw we're using. It just helps us when we're machining the part. And then finish with that. That completes the defined machine setup. Then just go to coordinate system. Make sure your coordinate system is correct. X, Z. We'll say OK. Stock manager. We use the bounding box for a round, round bar stock. That just uses the stock size, and we just increase it using the options down here. And remember, we set defaults last time. We can go ahead and load those. And again, you'll see that it adds 1.2 inches to the back of the part here. And then you see the representation of the 100 thou on the OD. And then if we rotate the part, you'll see the 100 thou to the front of the part. And again, that's as shown here in these parameters. And the material also, we say we want 6061. And then the rest of this is just we do a turn setup, and then after that it's just pressing buttons to get to a machine code, extract machinable features, generate operation plan, generate toolpath, simulate your toolpath, speed it up a little bit, and there you go. We see that display option, it's all green, it's good. And then post process, change the file type. I typically don't like to use the TXT, I like to use the NC. Save it. Remember, we just told where to save the file. Now we're actually going to save the file. So go ahead and select play. It shows us all the code that's being created. We can look through it. Not everyone knows how to grok the code, but it's all there. And then we'll say OK. And then it'll open up in our text editor. Here. And we have it set up for Fanuc milling. Let's go ahead and change that to Haas turning. Here, it was set up for, again, it was set up for Fanuc milling. We just want to change it to Haas turning. And then select backplot. And there's machine code. This is what the actual machine movements will be based on the G code that was outputted. Thank you very much. My name is Charles Woolridge. My email address will be included on the file that this is sent. If you have any questions, please do reach out to me. Thank you.